condensation for 1,700 days.
Disclaimer: the content on this channel is meant only to provide helpful insights, tips, and information on certain subject or topic. While we strive to provide accurate and up-to-date knowledge, this is not a substitute for professional advice. Always consult a qualified expert or professional for your specific needs. We encourage you to use this content as a guide for learning and additional information. If you think this does not fit what you want, please skip the video.
Why something will change. The state processes and the heat energy. Heat energy plays a crucial role in change of state processes where a substance transitions from one physical state, solid, liquid or gas, to another. These transitions include melting, freezing, evaporation, condensation and sublimation. Each process involves the absorption or release of heat energy, which affects the kinetic energy of the particles within the substance. The relationship between heat energy and changes in the state of matter can be broken down into the following detailed explanations. Understanding heat energy and kinetic energy. Heat energy is a form of energy transfer that occurs due to a temperature difference. It is transferred from a warmer object or environment to a cooler one. In the context of a material's change of state, heat energy influences the movement of particles or their kinetic energy. Kinetic energy refers to the energy of motion. In solids, particles vibrate in fixed positions. In liquids, they move more freely but remain close to one another. And in gases, they move rapidly and are spread out. During a change of state, the added or removed heat does not always change the temperature. Instead, it is used to alter the bonding between particles and the energy associated with their arrangement in different states of matter. Melting, solid to liquid. In melting, a solid turns into a liquid when heat is absorbed. Heat absorption. When heat is applied to a solid, the particles gain kinetic energy and vibrate more vigorously. This continued energy absorption weakens the bonds holding the particles in fixed positions. Melting point. At a certain temperature, the melting point, the solid's particles have enough energy to overcome the intermolecular forces that hold them together. The substance then transitions into a liquid where particles can move more freely but are still close together. Example: ice melting into water. When heat is applied to ice, the molecules vibrate faster until they can break free from their fixed positions, resulting in liquid water. During melting, the temperature of the substance remains constant until the entire solid has melted. The heat energy absorbed during this process is called the latent heat of fusion. Freezing is the reverse of melting, where a liquid turns into a solid as it releases heat energy. As a liquid cools, its particles lose kinetic energy and their motion slows down. Eventually, at the freezing point, the particles no longer have enough energy to overcome the attractive forces between them, and they begin to arrange themselves into a fixed, orderly structure. For example, water freezing into ice. As water loses heat, the motion of the water molecules slows until they form a solid crystal structure of ice. The heat released during freezing is equal to the heat required to melt the substance, called the latent heat of fusion. In evaporation, a liquid turns into a gas by absorbing heat energy. When a liquid is heated, its particles gain kinetic energy. As the particles move faster, some at the surface of the liquid gain enough energy to break the intermolecular forces holding them in the liquid state, allowing them to escape into the air as gas. When a liquid reaches its boiling point, the kinetic energy of all the particles is sufficient to overcome intermolecular forces, and rapid vaporization occurs throughout the liquid, not just at the surface. For example, water boiling to become steam. As heat is applied, water molecules move faster until they have enough energy to enter the gas phase. The heat energy required to convert a liquid into a gas is called the latent heat of vaporization. During this process, the temperature remains constant until the entire liquid has evaporated. Condensation is the reverse of evaporation, where a gas turns into a liquid as it releases heat energy. As a gas cools, its particles lose kinetic energy and slow down. The attractive forces between the particles become stronger, and at a certain point the gas particles can no longer overcome these forces, causing the gas to transition into a liquid. For example, steam condensing into water droplets on a cold surface. When steam or water vapor comes into contact with a cooler surface, it loses heat, and the water molecules lose enough energy to transition back into the liquid state. The heat released during condensation is equal to the heat absorbed during evaporation, and is called the latent heat of vaporization. Sublimation, a fascinating process, involves a solid directly turning into a gas without passing through the liquid state. This transition requires the absorption of significant heat energy. During sublimation, the particles in a solid gain enough kinetic energy to break free from their fixed positions and enter the gas phase directly, skipping the liquid phase altogether. A common example of this is dry ice, which is solid carbon dioxide. When exposed to room temperature, dry ice absorbs heat and changes directly into gas without melting into liquid. The heat energy required for sublimation is referred to as the latent heat of sublimation. Deposition is essentially the reverse of sublimation, where a gas turns directly into a solid without becoming a liquid, usually when it releases heat energy. A familiar example of this process is the formation of frost on a cold surface. Water vapor in the air deposits as solid ice crystals on cold surfaces like windows or grass without becoming liquid water first. In all of these state changes, latent heat is a key concept. It refers to the heat energy absorbed or released by a substance during a change of state without changing its temperature. The specific types of latent heat include the latent heat of fusion, which is for melting and freezing, the latent heat of vaporization for evaporation and condensation, and the latent heat of sublimation for sublimation and deposition. The absorption or release of latent heat allows substances to change states, but the energy is used to break or form intermolecular bonds rather than to raise the temperature. Heat energy is essential in state changes as it affects the kinetic energy of particles in a substance. By absorbing or releasing heat, particles either gain enough energy to overcome attractive forces, as in melting, evaporation, and sublimation, or lose energy and are pulled together by these forces, as in freezing, condensation, and deposition. In each case, the process of changing states is accompanied by the absorption or release of latent heat, which allows the substance to transition between solid, liquid, and gas without a change in temperature until the state change is complete.